We're always learning new things about our own planet. In just the last century, geology has brought us the theory of plate tectonics and taught us about the existence of ancient supercontinents. But we may just have discovered something that changes everything we thought we knew about Earth's internal makeup too. This is Unveiled, and today we're exploring the extraordinary discovery that the Earth's inner core is not what we thought. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. Until a landmark study in 2021, we believed for years that the structure of our planet was thus. On the outside, we have Earth's crust, divided into continental and oceanic. Further down, we have the mantle, the thick, hot layer of vicious rock that fuels volcanoes. Then we have the core, separated into the inner and outer core. The outer core is liquid, and its movement is what generates Earth's magnetic field. Without this field, the solar wind would strip away our atmosphere, and we'd be exposed to solar radiation and the vacuum of space. The inner core is our point of interest here, however. Previously, it was thought to be solid hot white iron, compressed by the immense pressure of those other layers. But a new study conducted by Rhett Butler, a geophysicist at the University of Hawaii at Manoa, and Seiji Tsuboi, a seismologist at the Japan Agency for Marine Earth Science and Technology, suggests that Earth's inner core is actually mushy. This means that it's made up of both parts that are hard, as we'd expect, but also other soft parts of molten metal. They found this out by studying data from years of earthquakes, as the seismic wave of an earthquake changes depending on what kind of material it passes through. By looking at the seismic waves on the opposite side of the globe to the earthquake's point of origin, we can learn valuable information about the Earth's composition. And as Butler put it, quote, "The inner core is not uniform. Instead, it's partially hard, partially soft, and even partially liquid. Hence the description as mushy." This study isn't conclusive, and Butler has said that much more research needs to be done, but it's definitely interesting and a promising step forward in understanding the inner workings of the third rock from the sun. It'll help us learn more about magnetic fields and atmospheres in general, which will aid in our studies of other planets and perhaps even stars. The interior life of large celestial bodies remains deeply mysterious because of the sheer difficulty of studying them. We simply cannot go to the center of the Earth because of the heat and pressure. The temperature of the inner core is estimated to be almost 9,400 degrees Fahrenheit, while the pressure is over 3.5 million times greater than the pressure of the atmosphere. For comparison, the pressure at the bottom of the Marianas Trench is 1,086 times greater than the surface. Anything trying to tunnel to the center of the Earth to see what's down there would quickly and thoroughly be destroyed. We can use the information we learn about Earth's core in studying, for example, Mars's core. It's well known that Mars's magnetic field is so weak that its atmosphere has been almost totally destroyed by solar winds. Today, the Martian atmosphere is extremely thin and made up almost entirely of carbon dioxide. The reason for this is that Mars's core is solid, though it may still have a partially molten inner core. Without the core to move around, no magnetic field can be generated, and the atmosphere is blown away by the sun, while the planet bakes and its potential to host life is eradicated. But how Mars's core solidified in the first place remains mysterious. Some theories suggest ancient collisions with massive asteroids are to blame, but in reality, we don't know either how or even when it happened. Studies that try to pinpoint when have ranges in the millions of years. The cores of gas giants are even stranger. Weird as Mars is, at least it's a terrestrial planet similar to Earth. It's generally believed that there are rocky cores in the hearts of the gas giants. But much like with a rocky planet, the temperatures are too high and the pressures too great for us to send a probe to see for ourselves. There's only one way we could get up close and personal with the core of a planet: finding one floating through space that has, for whatever reason, failed to become a true planet. In 2020, scientists did find such an object orbiting a star 730 light-years away. It was a large, massive body initially thought to be a gas giant itself, but upon examining it with a spectrometer, a device that uses waves of light to determine the chemical makeup of distant objects, it was found to be made of rock. And it's still hundreds of light-years away. We can't just go over and look at it, but it's still a good window into what the core of a planet actually is. It's thought that this particular core belongs to a so-called failed planet. Much closer to home, we have metallic asteroids like 16 Psyche, which is potentially part of a planetary core in our own solar system. 16 Psyche is, on average, only 27 light-minutes away, and it's found in the asteroid belt. It's not molten because it doesn't have the mass of a planet around it contributing to pressure and friction. But there are yet stranger theories about what might lie beneath Earth's surface, ones that don't rely on us studying distant planetoids. For a while in the 17th century, the belief that Earth was hollow gained some traction. This had already fallen out of favor by the 1800s, and it hasn't had the resurgence that theories like flat Earth have. But for a while, this bizarre theory was believed by many. The idea is that the Earth is hollow and that there's an entire separate ecosystem contained within. There's even another sun, an interior sun, to illuminate this strange subterranean world. You might immediately recognize this idea as the core premise of one of Jules Verne's many seminal science fiction novels, Journey to the Center of the Earth. But Verne wrote his book long after hollow Earth theory had fallen out of favor. Before Verne, some people did really believe that something was going on inside the Earth, and it remained somewhat common to believe that there was some kind of void or gap beneath Earth's crust. Whether that void was populated by long-lost dinosaurs was a different matter. Weird as this sounds today, it does of course have a large precedent in folklore and mythology. Hell, the underworld, and many forms of afterlives from different cultures are often represented as, or believed to be, underground. In ancient Greek myth, it's common for heroes to actually travel to the underworld themselves while still alive. Orpheus famously does this in his pursuit of Eurydice, while Heracles went underground to defeat Cerberus as part of his 12th labor. In the Divine Comedy, when Dante travels to the afterlife and ultimately descends into hell, he does so by stumbling through a cave and coming across the land of the dead almost by accident. So this belief that there is something strange far underground has been shared by many cultures throughout human history. And the hollow Earth theory and descendants of Vernian fiction are just part of this tradition. But what's the closest we've really gotten to the mysterious center of the Earth? Earth is full of complex, crisscrossing cave systems that have been explored to varying extents. Caving is a dangerous and unique hobby, and definitely not one for anybody with a fear of the dark or claustrophobia. But people have still descended to remarkable depths this way. One of the deepest yet found is the Krubera Cave in Georgia. A 2012 expedition spent a spine-chilling 27 days inside the cave, descending to a depth of over 7,200 feet. Elsewhere, we've tried to dig our own holes as far as it's possible to go, with the deepest being the Kola Super Deep Borehole. It was a project conducted by the Soviet Union as part of an extremely weird chapter in Cold War history. Forget the space race. The race was on to drill to the Earth's mantle. However, unlike the moonshot, neither the Americans nor the Russians completed the feat. The borehole is today more than 40,000 feet deep. Luckily, it's now welded shut, and regardless, it was too narrow for anybody to fall inside, like Dante. Much of our planet remains mysterious, but that means there's always more to learn. And this study into Earth's inherent mushiness is a vital step towards understanding our home. And that's why Earth's inner core is not what we thought. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.